This is Programming Chapter 7, Part 2. We're going to be looking at creating a class that can be used for linked lists. And this is known as a single linked list, as opposed to a double linked list, which we'll learn about later, but it's not required for you to do any coding for that. It'll be bonus work. So all we have to do is add a pointer to our class. So this is a node, and this is a pointer. And to have this class work, we need a head node. It's just a dummy node. In our nodes, we're going to have numbers and a pointer. Of course, you can have anything we want for your node, but we're just doing numbers to simplify the concept.
The head node should be initialized to a value that's not in your list, kind of like a sentinel. And in this case, we'll use -1.
Initially, the pointer will be 0, which means it points to nothing. There's no list. So we always have to have a base condition when we're doing data structures. So our base condition is -1 for the head node and points to nothing. If we allocate a node 1, we can give it a value, say 10, and its pointer will be 0. This is not a linked list yet. What we need to do is add this node to the linked list. And we can just add it to the end of the list. So we get rid of the 0, we go through the list until we hit a 0, and then we add the node. So now we have a list consisting of the head node and node 1. If we add a second node, give it another number, say 7, it will point to 0. We call a function, we add it to the list. We go through the list, and we find the 0, remove the 0, and point to the new node. So this is basically how we create a node and what it looks like, and it always ends with a 0. When it ends with a 0, means there's no more nodes added onto the list. Now let's take a look at some code. Here's our basic node, and here's all the functionality that we're adding to the node. Here's the start of our program. We have a list, and it's initialized to -1. It means that there's nothing in this node. It's just a dummy node. We create a new node, node 1, and this constructor initializes the value of the node, and it manually adds it to the head node. So it manually added this node. It just takes the pointer from the head node, changes it to the address of node 1. And for node 2, does the same thing. It creates a new node, gives it a value, and it manually takes a pointer of node 1 and makes it point to the address of node 2. So it does this part. Let's take a look at the code. We'll run it. Set a breakpoint here. And we'll run the program. Okay, we have a whole bunch of local variables here. We won't need this, so I'll close that. And we'll step over. So we create a head node. This is list. It has a -1 in it, and it's pointing to nothing. It's got a 0 value in it. All these CCs means that these variables are uninitialized. So let's step again. We've created a node 1. It's down here. It now has an address, and it has a value, and it has a null pointer. We look at list. The next has been set to the address of node 1. We see that the addresses match. Now let's step into this next routine. We're creating a new node 2. We step. So the current node is node 2. It doesn't have a value set. We're going to set it to 18. And the previous node is node 1. And we'll step. So now the previous node, its next pointer is set to this new node that we're creating. And now we initialize the number. And even though next is already set to 0, it's always good to explicitly set this in your constructor. And we return, and we see that node 1 is pointing to the address of node 2. And with this debugger, we can just follow the links. And we get an error when we try to read the object when it's null. So we can close that one. We can see that this next has number 18, this next has number 13, and the first next has -1. So that's our whole list. So in the sample program, we're creating a third node, but we're not calling the manual linkage. It's calling a function that adds the node to the end. So it starts at the head node, it goes through the list, and once it finds the 0, it's going to add node 3 to the end of the list. But this function hasn't been done yet. It's up to you to fill in the function with the proper code. So to help you through this, I've already programmed the print routines, and we'll trace through this. And we'll step into. So it starts off, we don't want to print the head node because it doesn't have a value that's valid for our list. So we simply say the current node is equal to the next node. And we can examine this. It has the value 13. And we print that number. And then we say current is equal to current next. And if we look at this, this is pointing to node 2. So watch the numbers change here. We're going to step. Now the current one is pointing to 18. And now the next one is pointing to nothing. So we'll loop again. And current is still valid. It's not pointing to 0. It's going to print the current number, which is 18. And now current is going to equal the next pointer. And it's 0. So when we get back to the top of the loop, it's a 0, so it stops looping. It prints a new line feed, and it returns. You need to understand that piece of code to fill in the rest of all the functions. Now I'm going to describe how to do this. So the first routine is add node to the end. We're going to take the head node, but we're not going to skip to the next one. We need to check to see if it's 0. It's not 0, so we move on to the next node. Again, this one is not 0, so we move on to the next node. This one's 0, so we stop here. And we assign this the address of node 3. So we're going to be passing in the new node as a parameter. And then this pointer will get set to 0. And then you return from the routine, and that's all you have to do. It's void, so you're not required to return anything for this routine. The next function is getNode. You're going to search the list for a number, and then once you get that number, you're going to return. So let's look at the code. Suppose we're looking for the node holding 7 in it. We start at the head node. We don't check the head node's number because it doesn't have a value that we want to check for. Remember, it's a dummy node. So we skip the head node, just like the print function. We compare the value. 7 does not equal 10. So we go to the next node. Once we go to the next node, we compare. It matches. So from here, we just return the current node. And that's as simple as it gets for current node. If for some reason we get to the end of the list and we see a 0, we need to return a null. And that's what the comments say. If you reach the end of the links, you return a null. And the comments give you a hint on how to create the code. The next piece is get node index. Okay, so this time we're just going to count through the list. Erase this. Okay, so let's say we're going to return index 2. So we'll have an index counter. We started at 0. We skip the head node, we go to the first node, and we compare the index to the index that we're looking for. No. So we have to increment the index. It's now 1, and we skip to the next node. Do the indices match? No. So we skip to the next node and increment the index. Now they match. And this is our current node, and we'll return current. And that completes that routine. Let's go to the next one. Sort node. Okay, so these nodes are no good. We have to start from scratch. We'll have a sorted list. We'll assume that these are sorted right now. So head node, node 1, node 2, and we'll call this node 3. Say it has an 8. This is our new node. And this one is a little bit trickier. We start at the head node, and what we need to do is we need to compare our new node with the next node. Okay, so it's very important. Compare to. Okay, so we compare to the next node's num. If it's less than, then we need to insert it into this spot. And the reason why we need to compare to the next one is once we advance to the next node, we've lost the pointer here. I'll demonstrate on the next node. So it's not less than. So we skip to this node. Current is here. Now we're going to compare node 3 to the next node of the current node. So we're comparing to here. 8 is less than 10, so it needs to fit in between here and here. We need to move this pointer down to here. And then we erase this one, and this one will point to this node. So it's a little bit tricky, but step through the debugger to make sure you've done all the assignments correctly. So once we find this node, it needs to go from here to here, from here to there. And this one still has a 0. And if we run into the current node with a pointer 0, so suppose it's like this, and this number was now 18, there is no next node to compare to. This pointer is now pointing at the last node. So if we come upon a 0, we simply do it like the add node to end function. And that completes that routine. Now we have a delete node here. The delete all function is already done for you, so you might want to look to that as a clue of how to do delete. But delete is very much similar to sort node. Let's say we're deleting the node that has the value 10. We have to do the same thing as sort node. Current will point to this. And then we check the next node. It has a 7 in it. So that's not the node we're looking for. We advance current to here. Now we check the next node's value, and it is 10. So we need to remove node 2 from the list. So basically, we get the pointer from node 2 and put it into node 1. So we put the pointer there. And we remove the pointer from node 2. And we can deallocate it. And it's important to deallocate it, otherwise you'll have memory leaks. So in C++, we just call delete and the node that we're going to delete. Notice that we save the pointer here. We set the pointer here from the previous object to the next object, and then we delete the node. If you just set it, you're going to lose the pointer to that node, and you won't be able to delete it. And that covers all the functions you have to program. And this is what the sample output should look like. Please do not change any of this code. This is your test data. The only code you should change are the functions that you've been asked to change. And that completes this lesson. Go on to part 3 when you're ready.